Hello everybody, welcome back to another video. So today's video is on the different types of techniques used in computer graphics. These include software rasterization, ray tracing and path tracing. I'm going to be showing off the three different images that I have produced using these techniques, and I'm going to explain each of them as best I can in the simplest way possible. So let's get started. So first up is my software rasterizer. So pretty much how this technique works is that it takes vector data and transfers it onto pixels on a 2D screen. Each 3D model in my scene is built up of polygons, which are built up of vertices. The rasterizer pretty much takes each vertice from the polygons and calculates where to put them on the screen. Once it's done that, it then processes the distance between each vertice and sort of fills in the space in between them to create one face, turning it into a group of pixels on the screen. And that's pretty much the gist of it. So that's pretty much how this scene has been created. This technique is very popular in video games as it can produce images quite fast and you can render stuff very quickly, which is obviously very good for video games if you're trying to get the best performance out of your game. Okay, so moving on to ray tracing. So pretty much how ray tracing works is that rays are emitted from the camera through each pixel within the scene. And when a ray hits a surface, it then calculates the angle relative to each light source within the scene, and then determines whether it should be lit or shaded, etc. You can create cool effects with this, like rays bouncing off each object to create reflection effect, etc. So yeah, we can use programming to create different types of materials and determine how the rays react to different types of materials. I had a pretty big issue with my metal material within my scene. As you can see, the objects are pretty much all black. We have a little bit of light reflecting on the helmet. As you can see, it's a little bit yellow. But yeah, I didn't solve the issue when it came to submitting. I just couldn't really figure it out. I found out that it was to do with the normals, and I couldn't really figure it out towards the end. But either way, we have this scene right here. We have the light source behind the objects, and yeah, that's pretty much my ray traced scene. Okay, so moving on to my favorite of the three, we have path tracing. So with path tracing, it is very performance heavy and isn't used in video games as of yet. I know NVIDIA are sort of working on implementing it into video games, but they haven't sort of perfected it as of yet. It is currently being used in films and stuff like that to generate realistic images. But pretty much how it works, it sort of takes the same principles as ray tracing, but as with ray tracing, one of the rays bounces off the object, but what path tracing does, it reflects the ray, but then it also generates other rays going off in different directions. Sort of because, like, if you think about it, light comes from everywhere in the room. So even if a light source is coming from the window, there is still light being bounced off walls and loads of different directions that light is coming in from. So it sort of tries to simulate that by bouncing the light off in random directions. It works quite well. As you can see, it generates a very realistic looking image. But yeah, it's very, very performance heavy and is yet to be implemented into video games. So hopefully that explained it quite well. But yeah, as you can see, it is definitely one of my favorite images. The other two are not as pretty as this one. So yeah, that's gonna sum up the video there. I hope you all enjoyed. It is once again another uni video, so this isn't like my normal type of videos that I make. But yeah, I hope you enjoyed either way. The next sort of videos are going to be a devlog series on a mobile game that I'm making. So yeah, more Unity stuff to come. So yeah, I hope you all enjoyed, and I'll see you in the next one.